Okay, once again, to use fork, you need a new library called as include uni_std.h. And let's see how it works. If I do print f, I say welcome to C. Okay, if I run this, what should be the output? There's nothing here. If I just run this, what should be the output?
Welcome to C.
Just welcome to C, nothing. But now look what happens. If I just put a fork here, now if I run this, what do you think will happen?
Welcome to C will be twice.
So now, because of the fork, the whole process gets repeated again, and the print becomes twice. So look at that. And you can put \n. Have it in the next line. So did that make sense? When you give a fork function, the whole function gets repeated again. So what if I give it 2 times?
Print it 4 times.
If I give fork 2 times, the answer is printed
4 times.
Okay, what happened here? This is a glitch in the software. Okay, let's run it again. Yeah, it takes time to process, yeah? So write down, if you give fork 2 times, it should run output 4 times. What if I give it 4 times? Hold on. Okay, what if I give fork 4 times? How many times?
16.
Okay, let's see. So if I do this, the answer is 16. What is the pattern here? Square of what? Yeah, that's a good guess. Okay, let's see, it's a good guess. What if I give 3 times? What should be the output then? How many times? 6, 9, or 8?
8.
The answer is 8. So write down it's 2 to the power of n. So if I give 2 times, the answer is 2 to the power of 2. If I give 3, then the answer is 2 to the power of 3, which is 8. If I give 4, then 2 to the power of 4, which is 16, and so on. Okay, and this phenomena can be explained by a tree diagram. So write down the tree diagram for the fork function. I look here. We don't talk. Look here. So the question is, draw a tree diagram for two fork functions. So given two fork functions, so for example, you give two fork functions, and the question is, give a tree diagram for this one. So let's see how to do that. Pick a circle. Which one is the circle? Let's see this one. Okay, say this is the first fork function. Wait, listen. Guys, don't talk. So this is the first fork function, and the program runs. What should happen? The process gets converted into how many processes?
Two processes.
So you say that this guy gets converted into so this is the same one and a new one. Let's fill this in. So this guy is the same one, and this guy is the child. Does that make sense? This is the first fork. Now if I give fork again, what do you think will happen? This guy gets converted into 2, and this guy also gets converted into 2. So this guy goes as it is, so this guy is the same. But this guy creates another child. So let's say this guy is another child. And then this guy goes the same. And this guy creates another child. So that's why at the end we end up with 4 outputs. Does that make any sense? So when you get 2 forks, we ended up with 4 outputs like that. 3 new childs. The one guy was the same at the beginning. This guy was the same. But then this guy gave birth to this. And then he gave another birth. And then this guy gave another birth.
One guy gave 2 births.
One guy gave 2 birth, let's see. Yeah. Yeah. Does that make sense? Yes or no? And now make a note. Every fork function has a function ID. Difficult bit, write it down. Every fork function has a function ID which it returns. So every fork function has a function ID which it returns. So just like the main function returns 0, the fork function also returns a value. So now write down the next step, how to find the function IDs of the fork. Let me know if it's too complicated. How to get the function IDs of the fork. So this is how you do it. In the fork function, you have to define it as a variable. So you have to say int fn underscore id equals fork. So what happens is the return value gets stored into fn underscore id. So guys, look here. And then in the next line, you print out the function ID. So you say function ID is, what should I say? %d or %f? %d, because we're defining as an int. And then comma. What should I put after the comma? fn underscore id. Can somebody explain what are we doing here? What are we doing in this problem?
Finding the function ID.
Very good. We're finding the function ID of the fork function. Now let's run this. What happens? Look at that. Why did it give me two IDs?
So the fork function is
Right, because the purpose of the fork function itself is to make one process into two processes. So now make a note here. The function ID of 0 is always of the child process. So the child process always has function ID 0. And this is the function ID of the parent process. These are all technical bits we are learning now. Okay, now write down the next thing. Other than the function ID, there is something called as a process ID as well. So now the process ID of the fork function. Other than the function ID, there is something called as a process ID. That is the ID of the code. It is not the return value. Hey guys, don't talk. It is the ID of the code that is running. Write down to get that. We need two new functions, which is called getpid. The other one is called getppid. PPID. The first one is getPID. It means get process ID. And the second one is called get parent process ID. Get PPID. Alright, this is how we do it. You just define fork. And you give two prints. Then you say child PID percentage D backslash N. Take notes, okay? I'll give you time to practice and help you. But take notes for now. And instead of the fn underscore ID, you have to say get PID. Get PID, open and close bracket. And then the next line you have to say printf parent PID %D backslash n, then a comma. What should I say here? Very good. You have to say get PPID. And will you get an output as a 0 here? No, because these are process IDs. They are not function IDs. If I run this, let's see what happens. Fingers crossed. Error. What is the error? Yeah, we missed the semicolon here. Very good. Let's run it again. And look at that. So can somebody explain what is going on? So let's try and understand this with a diagram. How do I? Okay. And how many forks are there here? There's one fork. So this guy gives birth to itself and a child. Can somebody explain why the output has three different numbers here?
It was repeating, but not on the exact location. Changing the
Close, yeah, close. Because this guy was also run by a parent process. So it means above this guy is another process here. Because the initial fork was also running in some process. So here's a question. What is the process ID for the first one? The smallest number here is?
1131.
No, 1124. Right? So this guy's Process ID is 1124. What is this guy's process ID? 1131, right? Now this guy is the same. So the process ID for this one is also
1131.
And the process ID for the child is so now if you look at the output, you can see that 1131 is repeated twice. Once as a child and once as a
Parent.
so in the first one, it is a child. So when it gave birth to this guy, it became the parent. Does that make any sense? On the midterm, you'll have to make a tree diagram as well, make a note with the process IDs. Not on next week's quiz, but on the midterm. Okay, up till here for today. Let's stop here. Up till here for today. Now practice this much. Stop recording.